So now we are going to start with the lenses, right? Lenses, lens. Lens is transparent medium, transparent medium, right? Transparent medium, light, light, light rays get refracted, refracted when pass through lens, right? So when when refraction occur through through when refraction occur through spherical spherical glass surface form spherical lenses, spherical lens, right? Okay, so if you take two spheres like this, one is like this, another one is like this, right? This is, so this is having a set, this is center, right? And this part, this we call this we cut out and form lens, right? And the line joining two centers is known as, this is known as principal axis. This is called principal axis. Principal axis. This is called, this O center is called center of curvature. Center of curvature. Curvature, right? And half of it is focus, right? And this is the line, and this is called, this point is known as, intersecting point is known as optical center. Optical center, right? And distance between these two, distance between these two is known as focal length. Focal length. Distance between optical center and focus is known as focal length. Right? This is the refracting surface 1. This is refracting surface 1. So it is C1 and its focus is F1. This is refracting surface 2. So this is C2 and this is F2, right? And this is called convex lens. Ready? Now another type of lens you have, if you keep two spheres like this, one sphere is like this, another sphere is like this, close to this, and this is this is the sphere close to the, this is having, this is this is refracting surface, this is refracting surface 1, this is refracting surface 1, so this is C1, and this is refracting surface 2, so this is C2, right? And when you join it like this is like this, right? So this we get is, this is we have, right, line joining two centers is known as principal axis. This is principal axis, and this is, this is center of curvature. Sorry, this is optical center. This is again optical center, right? And there is F1, this is F1, this is F2, fine. So this distance between F1 and O, optical center, distance between optical center here and is known as focal length. Focal length, right? Did you get this? Right? And so, and this is, we have concave lens, right? This is convex lens, this is concave lens, right? Right? And convex lens, focal length, positive, right? दूसरा, they are uh, thick in middle, thick in middle, and thin at edges, right? And they are converging, converging lenses. I hope you understand this. Con hmm? Oh my God. So what I wrote, focal length in convex lens, focal length is positive, thick in middle, thick in middle, and thin at edges, and converging lenses, right? And in concave, focal length is negative, right? They are thin in middle, and thick at thick at edges, right? And they are diverging lenses, diverging lenses, right? This much you have written. Okay, okay, do it. I hope done. Yeah. So this I'm going to rub now. Now we have this is a oh my god. This is a convex lens, right? Convex. Yeah, you can say that I'll discuss later. So what I told, its focal length is positive, right? This is the refracting surface 1. So focal length is on this side. This is F1, right? And here I told you focal length is positive, right? They are, oh my god, oh, what the hell is this? He gone away, where he gone? Uh, Hello. So yes, yes. So we it is it is uh, it is thick in middle, thick in middle, right? Right. Thick in middle, and converging means if light rays are coming like this, right? They get accumulated. So if light rays are coming like this, they get accumulated like this. So that's why I'm saying it is converging lens, right? So it is converging lens, converging lens, oh, lens, right? And another you have, as I told you, that is that is concave, right? Concave. This is concave lens, right? Its optical center is this, its R1 is this, and when you draw principal axis, so F1 is this, right? F1 is this, so F1 is this, and its focal length is negative, right? And this is thin in the middle, thin thin in middle, right? And when light rays are coming parallel like this, when light ray comes like this, right? It goes like this and seems to be coming from focus. Now this is like this, and this is parallel and coming like this, right? This is so uh, so this is what we have. That's why I'm saying it is diverging lens. Light rays are coming like this, they get deviated, it goes like this and seems to be coming from focus. So that's why it is diverging lens, diverging lens, right? Now we have two type of lenses, as you have seen here. One is this is concave lens. Oh, this is concave lens, concave lens. This is concave lens, right? And that is convex lens. They are again of three types, right? They are only again of three types. One is biconvex. Biconvex means when both the surfaces are bulged out like this. This is and this is. It is called biconvex. Then we have plano-convex. Plano-convex. In plano-convex, it is like this, and another one is one surface is like a plane, right? Like a plane, and another is curved. This is called plano-convex, and after that we have concavo convex, right? In concavo convex, what happens that one surface is like this, right? And another one, this is convex surface, and now we have concave surface, right? This is called concavo convex. Similarly we have three type of uh, concave lenses. First is biconcave. This is biconcave. So in that, like this, like this, right? This and this. This is this is called biconcave, right? Another one is another one is uh, yeah, plano concave. It is plano concave. This is plano concave, right? And then lastly we have this is this is concave surface, and this is convex, right? So this is we called plano concave concave, and it is convexo concave, right? I hope you understand this much. You have written doing. This is about lenses we have discussed. Should I rub? Okay. Now we have sign convention, right? We have sign convention. Sign convention. Sign convention, right? So, for a steady point of view, for a steady point of view, light rays, light rays, light rays always 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 travels left to right, left to right, right. So means from this is left, right, and this is right, right. If you make a Cartesian plane, so Cartesian plane is like this. This is y-axis positive, it is y-axis negative, right? And if you draw a line like this, so this is x-axis positive, it is x-axis negative, right? Right. Okay. So this is positive side, this is negative side, this is positive side, this is negative side, right? So when we are measuring distance, if your light is traveling in this direction, this is the direction of light, direction of light, right? And this is direction of measurement, direction of measurement, measurement. Then direction, when direction of measurement and direction of light, uh, when direction of measurement and direction of light is same, then distance in positive, distance in positive, positive, right? Like like focal length of convex lens image, right? And when direction of light and direction of measurement is same, then distance in positive, right? Like focal length of convex lens and image. Matlab, if you are taking 0 here and you are measuring towards this side, towards this side, this is positive side, right? And when direction of light is like this, when direction of light is like this is direction of light, direction of light, right? And this is direction of measurement, direction of measurement, both are both are opposite to each other, opposite to each other. Hello, then hello, hello, then 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 both are opposite to each other, then distance is negative, then distance in negative, right? Distance is negative, like like focal length of focal length of con concave mirror, concave lens, right? And position of object, and position of object, sorry, distance of distance of object, right? They are always in negative, right? This here we can write distance of image, you know. Maybe there will be a condition, maybe distance of image, right? So this is how you come to know that this is this side measurement is this side measurement is uh, this side measurement is positive, right? And this side measurement is negative, right? And one more thing, when object is vertically upwards, it is in upward direction, erect, 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 or upward, upward, right? Then positive, then positive, right? And when object is inverted, or downward, then negative, right? I hope you understand. Inverted or downwards, then it is negative. Virtual images are always positive, right? Virtual is always positive, and real is always virtual. Height of virtual, height of virtual, height of virtual is positive, and height of real is Yeah, a coin has two faces. Height of real is negative. Right? I hope this much is in sign convention. Right? Always. So one point which you should always keep in mind. One thing you should always keep in mind that that object. Oh my God. Distance of object. Distance of object, which we represent by u, is negative. Always, right? Always object is in front of lens, right? And height of object, height of object, height of object, which we always represent by O, is always positive, right? Because object is always upward. ठीक है? Object 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 always upward, right? I hope you understand this. So what I said focal length of concave lens, a focal length of concave lens is negative, focal length of convex lens is positive. Distance of object from the lens is always negative because always it is in front of lens and it is upright. When it is upright or in upward direction, so always its height is positive, right? Remaining things can be depend upon the position of object. Image formation is based on position of object. Where is object? On that basis, image will be formed. So distance of image can vary on the position of object in front of lens or type of lens. I hope you understand. Yeah, should I rub this? You're doing? Okay. Okay. You can take a screenshot of this. There's no problem at all because finding the things is very difficult. How I wrote in a very scattered manner, something like this, something like that. So it's very difficult to, you should understand this, right? For this, understanding is main. And now we will talk about three conditions for image formation. Now we are going to discuss after this conditions for image formation. One more thing I would like to say, told you here, but let me rub this. Okay. So Yeah. You know, first you should keep in mind that lens formula, lens formula is equal to lens formula is 1 upon f is equal to 1 upon v minus 1 upon u, where f is focal length, focal length, focal length of lens, right? And v is distance of distance of image, right? Image, and u is distance of object. I hope you understand this, right? Now for magnification, for magnification, magnification, for magnification, m is equal to I upon O, where I is height of image and O is height of object, fine, is equal to V upon U, where V is distance of image and U is distance of object. So this is for magnification. This is the lens formula which you have to keep in mind, right? This is very important to understand the things, right? This is, should I rub? You're doing. For everything you won't take a screenshot. For everything you won't take a screenshot, man. If you won't write it, you will not able to learn, right? That was complex picture, so I told you for that. Should I rub now? Now, image formation. Sorry, conditions. Important, important conditions conditions for image formation, right? First is if this is a convex lens, right? And this is a concave lens, right? This is a concave lens. You say, I'm wrong? This is convex, this is concave. This is concave, right? And this is the principal axis. This is the principal axis. This is the principal axis. Fine. This is optical center O. Optical center O. Right. This is F1. This is F1. This is C1. This is F1. This is C1. Right. So condition is that line parallel to the principal axis, light ray parallel to the principal axis after refraction goes through focus. Right? What I said? Light ray parallel to the principal. Light ray parallel to principal axis. Light ray parallel to the principal axis after refraction goes through focus. Right? And light ray parallel to the principal axis after refraction seems to be coming from focus. Light ray parallel to the principal axis after refraction seems to be coming from focus. Right? So, what is condition? Light ray, light ray, light ray parallel to parallel to parallel to principal axis, principal axis after 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 refraction, after refraction goes through focus, goes through focus, focus or 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 seems to be seems to be seems to be coming from focus, coming from focus, right? From focus, seems to be coming from focus. This is we have first condition. Second is light ray, light ray passing through optical center behaves like a normal. Light ray passing through optical center behaves like a normal, right? This was first. Now the second, light ray passing through light ray passing through light ray passing through optical center optical center, right, behaves like a normal, behaves like a normal, right? And the third and last condition is, this is convex lens, this is, you know, concave lens, right? This is concave lens. So this is, like this. This is like this. Now we have this is the principal axis. Just closing. Wait for a while. Just closing. This is optical center. This is optical center, right? This is optical center. Sorry, this is principal axis. This is optical center. This is principal axis, right? Huh? Okay. Now, now, now this is, you know, this is F2. This is F2, right? And this is F1, F1, right? So, oh, I get it. So, light ray from focus, light ray from focus after refraction goes parallel to the principal axis, right? Light ray from the focus after refraction goes parallel to the principal axis, right? And light ray coming to focus, right, like this, right, goes parallel to the principal axis after refraction. So light ray coming like this, right, seems to be focus, goes parallel to the principal axis, right? So last condition is light ray light ray light ray coming from focus, coming from focus after refraction, after refraction 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 goes parallel to principal axis, right? So what I told you, there are three conditions: light ray parallel to the principal axis after refraction, goes through focus or seems to be coming from focus, light ray passing through optical center behaves like a normal, and light ray coming from focus goes parallel to the principal axis. Here light ray seems to be going towards focus, but after refraction it goes parallel to the principal axis. Light ray is going towards the focus, but after refraction it goes parallel to the principal axis, right? So these are the three conditions for image formation we have, right? So I hope you understand this much. So this much is sufficient for today. Okay then. Thank you.